There is an online question I could ask.
Okay, please go ahead.
This is from Stephen Clark. Can Anthony Philippret or somebody else discuss the reasons for moving the Viper launch to 2024? Thank you.
Yeah, hi. Primarily, it was, as it's been said in various press releases, it's to balance the risk with mission success. When all things were considered, the CLPS office asked the Astrobotic to do some additional testing of the Griffin lander to ensure its success in delivering Viper to the surface. And those additional tests requested by NASA just pushed their schedule out to the extent that we would miss the South Pole opportunity. We want to go to the South Pole. We don't want to go to the North Pole. So that necessitates essentially a 1-year movement to the right so that we get back to the same pole for the same seasons.
Thank you.
Okay, thank you. We do have some people in line here. So Ben.
Yeah, question for David. Oh, you've got a mic. So you spent a lot of time looking at the polar regions as a place for crew to explore. And I'm curious to know if you could pick one new data set that would help you continue your work, what would it be and why?
Okay. I'm still very keen to have a mobile element on, and it could be precursor robotic mission, a robotic rover, a small robotic rover, or a crew size rover that does subsurface surveys. So ground penetrating radar and neutron spectrometer on such a vehicle that gives you a sense of what's beneath the surface, I think would be very telling as to where astronauts might be able to do detailed sampling, detailed excavation, evaluate the context of any volatiles that might be there that might control the distribution of those volatiles. You know, as a lunar petrologist, I'm very keen to understand things like the lunar magma ocean, the lunar cataclysm hypothesis, but if we are going to be in the South Pole region to see if we can find resources for a sustainable program, then understanding that subsurface environment to me seems to be a high priority.
Okay, thank you.
Okay, we have another question in the room. Dan?
Dan Britt, University of Central Florida for NOAA. Given that your early teen spacecraft is maturing and perhaps going through puberty, will they be, like many who go through puberty, they learn new tricks. Are you going to be able to, is this thing going to be able to do perhaps data relay from spacecraft on the backside of the moon?
The short answer is no. The after a beer answer is still no. It is
3 beers?
feasible. 3 beers, then absolutely, we'll go to town. It's a cost thing. We have a limited amount of window left. How much time do we want to put into writing new code, new computer software, testing it, uploading it? We have a science mission that is spectacular. And anything we do for comm relay, I wouldn't build an architecture that relies on something that has never been tested on LRO to be done. So, and John, who is in the audience, he can do the 3 beers and answer the question for you. But Dan, the short answer is no. It's not, you know, if we had done this 10 years ago to implement now, the answer is still, well, I wouldn't want to design a mission on it. You know, it's challenging. It would have been something if LRO had been planned to do, it would have been spectacular, but let's keep LRO a science-focused mission, and let's put a comm relay and a series of comm relays at the moon to do the job, and not have LRO cobble together something, because that would impact science. And right now, let's run out the calendar on LRO as a science mission for the next 3+ years.
Okay, thanks.
Okay, Marshall, do you want to ask your question?
Yes, this is for Rachel, and I was just asking, can the can the Trailblazer actually confirm the 6-micron detection that Sophia has done for the moon? Will it have a 6-micron capability?
No, we, me and Noah are like the nobodies right now. We don't go out to 6 microns, so we can't confirm that, but we will be able to see the full extent of the 3-micron band. So, yeah, and we talked about whether the mid-infrared could do it, but it's not designed for that, so it doesn't go short enough.
Thank you.
Okay, questions? Anyone else?
So I have another question if I could ask. I don't see anybody that's in the line. Would that be okay?
Yes, please.
So this is actually a more general question. There has been there's evidence of a dynamical modeling evidence that the moon went through a high obliquity event maybe 3 billion years ago that may have baked out the lunar polar regions. How would the stuff that we're sending to the moon right now test that theory? Or can it test that theory? Have people thought about that?
Yeah, I can speak real quick to that from a Viper perspective. One of the authors of one of the studies, Matt Siegler, is our thermal lead in Science Co-I, and actually in the area we're studying, they prediction, it's a model, that there are places that have been both persistently a PSR, given the obliquity change of the moon, and areas that were a PSR and have been warmed, and areas that weren't a PSR and now are a PSR. And we'll be visiting all those regions very specifically to address that question, and doing drill sampling, seismic sampling, mass spectrometry, et cetera, to see if there are any differences detectable between those various states.
Can I jump in as well?
Sure.
Okay. Yeah, with Lunar Trailblazer, we can also follow up on the differences that Shuai Li saw in the nature of the absorption bands up there. So we can, look at where the pole would have been possibly, and where the pole is now, and some of the differences to see if maybe there is that more buried, sustained older ice somewhere, off the main pole, the current pole. So we will have that capability as well through our targeted observations.
And certainly I'd add on top of any mini RF observations that have been made or can be made in the future. Again, we have some of the most spectacular instruments at the moon presently and about to get to the moon, and models, we can validate test models so that Viper 2 Electric Boogaloo can go to those places and do the follow-on observations and in situ observations to test those models. I'll end it there because Paul Lucy has a question. We must answer Paul.
Rachel, can you come back? There's a question for you. Marshall or Alex, do you want to ask it?
Right, I can take this one.
Will it be a PS program for Trailblazer?
Is that, a participating scientist program? We would absolutely love to have one, but I think that's NASA's decision. So we are very supportive of it. We would love to invite others. As I mentioned, we're doing this on a very, very, very tight budget. So the science team that we have right now is working with with a lot of competent time. But we would love to expand that and bring on some of the experts in the field that are not already members of the team, if that is in the cards.
Can you hear me? Oh, Sarah, do you want to unmute and take a stab at that one?
I'm actually not sure either. I would say that it is not out of the realm of possibility, but it is not in our current budget, and we can take a look at that.
Okay, thank you. Okay, well, last call. I'd like to thank our chairs and all the speakers from the last session. Thank you very much.